Brilliant. Well, thanks everybody for tuning in. Like I said, I'm just going to say a few words for those of you who this is your first LJC event, or if you're tuning in afterwards from all around the world. Just as a bit of background, the LJC, or the London Java community, is also known as the London Java user group. Very well established and highly active group here in London. We've got over 7,500 members now. We've had upward of 600 events, and we are 13 years old, 13 and a half years old now. But what's special about the LJC and what stands out is really what makes it what it is beyond those numbers. And that's really that it is this show of the power of community, and that what we can do by collaborating together is just so much more powerful than working as individuals. Now, for me personally, my passion is all around the mentoring, personal development, and that kind of thing. So we like to bring speakers together, and people want to learn, and people are happy to teach. Then we're happy to put this platform together for people. But there's been a lot of work on the tech as well, and what we've achieved in the LJC on the tech side in terms of adopt OpenJDK, adopt JSR, all the amount of things that we've done. You can go and check it all out on the website. But yeah, that's really what we stand for here at the LJC. So as for who I am, my name is Barry Cranford. Like I say, I'm the founder of the LJC. And as many of you will know, I'm not a developer myself. I am in fact a recruiter. I run RecWorks, which is a recruitment company which specializes in Java placements. So at RecWorks, we believe that recruitment can be a force for good beyond just placing people. And what I mean by that is our work sits somewhere between giving back and paying forward to people that we hope to work with at some point in the future. So some examples of what we've done. We've organized the events within the LJC. We organised over 2,000 introductions now through the Meet a Mentor framework. And most recently, we've started a new aspiring speakers group. So if you want to be the next Peter Lorre, then obviously come and speak to us afterwards, and we can see what we can do. So you can find me on LinkedIn, find me on Twitter, yeah, I can help with any of that. So it's all ultimately powered by recruitment. What that means is we make no money from any of the events. The only way we get money is from getting people jobs. So if you're looking to hire at any point in the next 3-6 months, give us a shout. Likewise, if you're looking for a new role, then you know where we are. Anyway, with that, I'm going to get out of Peter's way and move on to this evening. So Peter is the CEO of Chronicle Software, which has several tier 1 banks as clients. He is a Java champion with the most answers for Java and the JVM on Stack Overflow. And he is an architect of a low latency Java trading libraries. Sorry, the architect of low latency Java trading libraries, which has been downloaded over 17 million times in 2018. So Peter, with that, I'm going to get out of your way and let you get on with this evening. Thank you for joining us.
All right, very good. So this is a talk I gave last year in Shanghai, and it was the first time I'd been to China properly, and I found that a lot of the things that I was talking about were familiar. Some of it is quite different because the markets are a bit different there, but many of the principles that I mentioned were still relevant, even in Chinese development. So a little bit about me, a bit more about me. I think we covered most of this, but probably the main thing that I point to is that I was the first one to get a gold memory, file I/O, and concurrent badges on Stack Overflow in any language. So it gives you some idea of my bent and interest. So the very first computer I had was an NEC APC. It was an advanced personal computer. It went a whole 5 megahertz, and the keyboard alone cost $2,000. That was in then money, not even today's money. It had 8-inch floppies, which also made good frisbees when they didn't work. The machine had 128 kilobytes, and I never found a use for all that memory in programming. I just didn't end up using it all, even though I programmed it for years. Eventually, one of the chips blew, and it turned out that replacing the base unit was cheaper than replacing the chip, because I could get the base unit secondhand. And I bought it off a guy who had a PhD in psychology. And I was asking, why was he learning to program? And he said, well, computers are easier to fix than people. And that's certainly something I found becomes more true as my career goes on, that as you get more familiar with the technologies you're working on, you feel much more comfortable with them, you become a lot more fluent in the languages that you're working with. Solving the people problem is always a challenge. That never goes away. It's always it's often the hardest problem to solve. So one of the things that I like to point out to people is that it's a real myth that developers spend most of their time writing code. An example I often give is that on one of the banks I was working for, I spent what I considered a very productive day coding. There was no delays, no interruptions, no meetings. I just coded flat out. And I wrote 700 lines of code, which I thought at the time was quite productive. And as an exercise, I printed it out and typed it back in again. I was trying to compare two IDEs to see which was a better IDE. Obviously, I had a favored IDE that I was trying to show was better, but nevertheless, the exercise was to just type in again what I'd written that day, a very productive day. And it took me about 45 minutes to type in. So what I'd actually produced, spent an entire day producing. So even on a productive day, I was only spending about 10% of my time writing the code that I would end up keeping at the end of the day. And that's on a good day. On a not so good day, I've spent like the entire day just trying to debug something and find one line of code that needed changing. So really, developers spend much more time trying to understand the problem. If you can spend even 10% of the time writing code that will be used in production, you're doing very well. And 10% is generous. It can be closer to 1% for many projects. Another thing that often strikes me is that when I graduated from university, they told us that within 10 years, 30% of graduates would be working in a field that didn't exist. Now, obviously, didn't really know what that meant because they're predicting industries that didn't exist, and yet that turned out to be the case. Things such as the World Wide Web, Java, even algorithmic trading, which are all things that I work on now, they didn't exist when I graduated. Java came in just a couple of years later, the World Wide Web a year after that. So it came in soon after graduate, but one of the things about this industry is that it's often hard to predict the technologies that will be really useful 10 years from now. And in many ways, it can be a bit of a wasted exercise. What you're much more useful is to develop skills and to maintain those skills. And that way you will stay on top of those areas. One of the reasons I've suspected many developers move into management is because they're sick of learning yet another technology all the time. And they see it much more productive to provide their experience to more junior developers. So that's why one of the reasons you tend to see over careers that people tend to move more onto the management side, because as I mentioned earlier, solving the people problem is often a bigger challenge than even solving the technical problem. One of the things that strikes me again and again, and even though I've said this, I've been reminded of this since I gave this talk, which is make sure that don't underestimate the importance of effective communication. So if you've made some improvement or you've done some work, make sure the right people know that you've done that. Make sure that there's appropriate documentation. If you add a feature to some code, but nobody knows about it, it probably will never get used. So you can do all the work, you can get it all working, you can do all the nice unit tests, but if you don't tell people about it and say why they should use it, it could be a waste of time. An example of this is I worked on a project about a year ago where it was given an interesting consulting task. They wanted to improve the performance and latency of a trading system, but they didn't want to change either the hardware or the software, which is usually where the first two things you might want to change. So I was a bit, I wasn't entirely sure how that could be done. So I thought, well, we'll start with the investigation. You know, why is it going slow? And I found basically three key things. There were a number of smaller things, but there were three key things that were slowing it down. And they would have required a code change, except it turned out in each case, someone had already written an implementation that fixed the problem. It's just that when it was written at the time, they didn't effectively communicate why it is that they needed to change to use this implementation instead. And so that wasn't used. So, so we were able to reduce the 99th percentile by a factor of 25 over about a month's work of engagement without actually changing the code or the hardware, by just enabling code that had already been written and being able to demonstrate why they needed to use that different implementation. In one of the cases, the code had been written 3 years previously, it just hadn't been used. So that's my point about making sure that people, if you're going to develop something, make sure that people know about it and understand how it's used. I've done this many times where I've written something really cool, but for whatever reason, usually poor communication on my side, people didn't realize its benefit or power and then didn't use it. And then other things which were really simple, weren't particularly awe-inspiring, but really easy to grasp what they did. They get used, you know, much more widely and much more readily. One of the things that came up is that when I started my career, for the first 10 years, I avoided any kind of public speaking, at least, and I didn't do any. And then at one point, I was working for Sun Microsystems in pre-sales, and basically was forced to do it. Was rather reluctant at the time, but after getting confidence and doing it regularly, I found that I actually enjoy public speaking, and I feel relatively relaxed. Not all the time, but often I can feel quite relaxed going into a talk and just really enjoy it. I found that made a big difference to my career overall. And I think it's a part of the effective communication, but it is actually something that I really believe can help people's careers, particularly if they feel like they're not getting, that they've got something to say, but they're not necessarily getting the attention for whatever it is that they're looking to, that they feel should exist, but doesn't yet. Another thing that strikes me again and again is that junior developers often look at how much they've added to the code, how much they've written, whereas senior developers often measure how much they got rid of, and it all still worked. So the first one is about contributing and feeling like you're being productive. But the second one is about maintainability, because writing code, a code might be written once, but it's usually read many times in order to maintain it. So code being read more often than written means that taking out code that doesn't do anything, or cutting it down and making it concise and readable and easy to understand is often just as important or more important. Another thing that, again, I was reluctant to embrace was the importance of having some form of regular exercise. In high school, I hated PE, physical education, and I generally avoided it. I never really thought of it as something to do with my career until, again, probably about 10, 15 years ago, where I started to realize that exercising helped with stress, helped me stay alert, be a bit more creative, come up with more original solutions. And it really does make a difference, I believe, particularly even for your career, not just for directly for your health, for your mental state as well. Now, one of the things that does come off again and again, and this tends to be more true of junior developers, but can also bite senior developers, is that they love solving problems. They love coming up with new and novel solutions, even if these are not problems that really need to be solved. Having that kind of discipline, I'm not sure whether that just comes with time or because you've done it so many times before, you've done so many projects before where you did things that didn't end up being used, that you will tend to focus more on what is actually required and to do exactly that, and make sure that you're solving the problem that needs to be solved from the requirements, not running away with, all these things are cool. Let's have a solution looking for a problem to solve, which can often be the case. One of the expressions is when all you've got is a hammer, everything looks like a nail. Another key principle that comes up again and again is, which is sort of related, is Yagni, you ain't going to need it. So one of the big mistakes is implementing something when you foresee that you have a need for it. I like doing this, but I try to treat it as a separate exercise. So often in my own time, I'll go away and try and think of cool solutions to problems, but try not to introduce it into like the core products, because that just adds bloat. And then when you come to seeing the real requirements, they might be inconsistent with what you've actually done. So you either have to rework it, or it doesn't quite fit. And you would have been better off never have implemented it in the first place, and started from scratch, as it were. So two of the principles that come up regarding trying to improve maintainability is there's dry, which don't repeat yourself. But I think just as important is to know when not to overdo it. So one way of avoiding repeating yourself is to have lots of levels of abstraction. But as you add more levels of abstraction, that may actually obscure what's going on rather than actually help. And so you can end up with less maintainable code by having too many layers of abstraction than just trying to keep it reasonably concise, and not necessarily trying to avoid all kinds of duplication. I remember seeing a C program once where they'd used a hash define to redefine while, so that while not or something like that. And then so they could essentially, a lot of the built-in statements of the language had been redefined to reduce duplication, but in reality you needed to know what they all were, and that actually makes a more conceptual load on the developer to try and understand the code. So one of the areas where duplication tends to be a bit more encouraged, I would say, is in unit tests. So in unit tests, it's less important to avoid duplication. It's still useful, but is not as important as it is in production code. And so having tests that are easy to understand, and you can see just by reading the test precisely what it does, is often more useful than trying to make the test as short as possible and remove all possible means of duplication. So, so one of the things that you tend to, the mistakes you tend to make starting out is to assume that it's hard to build a complex solution, but it's often, but in reality, the challenge is taking a complex requirement and producing a simple solution, right? So don't take a simple problem and build a complex solution. Rather, you want to be creating a simplest solution to cover a variety of requirements. And that's actually the biggest challenge is creating simple solutions which actually cover complex requirements. Yeah. So as I said, another principle which comes up again and again is what are the right separations of concern? So separations of concern can mean abstractions in your layers. So you don't want to have too few levels of abstraction so that everything is all the concepts are bundled together, but you don't want to have so many levels of abstraction that you have to jump all over the code to try and figure out, well, what does all of this do? You want to have the levels of abstraction are about right. In our code, it tends to be a fairly small number, somewhere between 3 to 10 levels of call stack and key levels of abstraction, but it varies based on the project. But you want to have the right levels in terms of layering. Another key concern is, particularly once you look at the business requirements, is how do you separate out the pieces of functionality? And this is where microservices have increasingly been used, even in trading systems. And certainly one of the features we encourage is microservices in trading systems. And there's two ways to structure microservices. One way is to structure it on functionality. That tends to work well when you have a small team that works well together, and then you can break it up your system based on key pieces of functionality, and you can all work on it together. What tends to also happen, particularly in larger organizations or maybe in teams where they don't work so well together, is you also arrange the microservices to reflect your organizational chart. So if you've got teams in 2 different regions, you may have them primarily working on different microservices, for example, not purely for technical reasons, but because that reduces the amount of interaction between the 2 teams that are required. You can even find it when you've got 2 developers that don't see eye to eye. So they can work on their individual microservices and they can implement them completely differently. But as long as the contracts between them are clear and compatible, those 2 microservices will still work together. So you can split your microservices either on a technical basis or an organizational basis. And sometimes it might be a bit of a mix of both. So one of the key principles I suggest around premature optimization is you don't necessarily want to optimize your code to death, but what you do want to do is keep your code simple. That makes it not only easier to maintain, but it also means that the JVM is more likely to do a good job of optimizing. It may not optimal, but it will do a good job. And the reason for that is that the JVM has a cookbook of patterns that it knows how to optimize. And so if you write really clever code, you probably won't fit into any particular cookbook. And so you won't necessarily get as efficient code as something that's just simpler and clearer. Then once you've got a realistic workload and you can see precisely where the bottlenecks are, then then it's a good time to focus on what bits are worth spending the time tuning to death. And generally speaking, that's a small portion. If you have even 10% of your code genuinely needs to be optimized, that's quite high. And a lot of the projects I've worked on, it can be as little as 1% of the code is the code that really matters, is used a lot, that needs to be optimized to death. And most of the code in reality just needs to run well. Not badly, of course, and not enough to impact the system, but not necessarily be tuned to death. So one example of this is in low latency is trying to keep low garbage, like low amounts of GC in your application. So what we tend to find is that as long as you're fitting within whatever your garbage rate budget is, you may find that most of your code doesn't need to be optimized, but there'll be certain operations and certain lines of code that produce far more garbage than others. And they're the ones that you will need to tune potentially. But you only know that once you've run it through a profiler and you've done it with with a realistic workload, because up to that point, you're really just going to be guessing. And there's been a lot of projects where I'm pretty good at guessing what the top 10, some of the top 10 causes of delays are, but it's often not the top 3. And I found that amongst other performance experts that really, until you've done the analysis, you're really just guessing as to what the biggest delays are. And in many cases, you're lucky if you can get down to the 2 or 3 things you thought probably would be a problem. There's usually something much bigger out there that only an analysis will find. As I mentioned before, trying to keep your code clean, readable, maintainable is certainly, to start with, more important than having your code overly optimized. That's an exercise that you should allow some time for later in the project, once you've got a realistic code set, realistic workload, and run it through a profiler or some sort of tool to give you analysis as to where the time's being spent. Another thing to think about is that 6 months from now, someone will be reading a code and may find it really confusing, and that person could be you. So I don't know how many times I've gone back through old code and thought, who in hell wrote this? And you look at the annotations and it was you, or you had a large part in it. So make sure that making your code clear and easy to understand will avoid frustration further down the line when you no longer remember all of the amount of immediate knowledge that you had when you first wrote it. Another big principle is that that I find again and again is that if you can pick up bugs earlier in the development life cycle, then that reduces the cost of fixing that bug. So we spend a lot of time focusing on different tools and techniques for being able to pick up errors sooner rather than later and fix them very quickly. And one of the key principles behind that is whenever you get an error, make sure that the error message is as clear as possible before you fix the bug that caused the error. Because after you fix the bug that caused the error message no longer comes up, and you may never get back to that. Whereas if you make the error message as clear as possible first, if it comes up again, then you will be able to, someone else or you will be able to fix that kind of issue much more quickly. So there's a lot of different kinds of driven development out there, and we tend to favor at the moment behavior-driven development. So notionally what you do is you start with your requirements, your behavior requirements, and then from that you might derive some lower level unit tests, and then you produce the code, and that goes around in a cycle. This is the ideal, and it's good to be able to get to that point. But I found from experience that that really only works if you've got a lot of experience in that space already. So it's much easier to write a unit test for a piece of functionality you've written before, because you understand all the edge cases and you understand all the things to look out for. You understand the functionality that you're trying to achieve. But if you move into an area that you really don't know very well or understand, trying to create test-driven development or behavior-driven development is very hard, if not impossible. And I ran into a project a couple of years ago where after doing behavior-driven development and actually writing behavior-driven development frameworks, I found that it just wasn't appropriate for a new project, which was to do with blockchain, because I just didn't understand it well enough to know what behavior I needed it to have, or even how to write test cases for it. What I ended up having to do is to go back to prototype-driven development, create a prototype, get that into a reasonable state, then as a next iteration, create, well, what are the tests that I should have been able to write in hindsight, create some test-driven development, and then from that migrate the code across, in many cases, just complete rewrites of the code. So, sorry, here's an example of high throughput blockchain. So started trying to do the behavior-driven development as I've done with previous projects. I found that it really didn't work because I didn't understand the space well enough. And in reality, if you think about if you can do behavior-driven development, it's because in a previous project you started from scratch, right? So if your very first project in a particular area is probably not going to be behavior-driven development, it'll be more on the rapid prototyping stage, and you go through some iterations, then you can get to test-driven development, then you can get to behavior-driven development. And so that's the goal. But assuming you can just jump straight to, well, if my goal is behavior-driven development, let's start with that. That's not always appropriate if you don't have enough relevant experience in that field. I've seen again and again the problem of trying to take prototypes into production. The reality is that you should always try and plan to rewrite any prototype. That can be a hard sell from a project management point of view. They'll say, oh, you spent 3 months writing all this code. But I go back to my earlier point is developers don't spend most of their time writing the code. They spend most of the time understanding the problem. Rewrites, if you take a project that took you 3 months to write, print it out, type it in again, you can rewrite it in a matter of days. And that's because all of that iterative development, testing and requirements capturing and figuring out what all the issues might be, all of that has already been done. That's where the time is being spent. It's not typing in the code. So starting to step into some of the low latency field. And one of the things that I find again and again is a challenge conceptually is that a lot of developers are familiar with the more web space or user interaction space where latency can be seen. So if you have a latency that's too slow, you can see that it is too slow and you get that feedback. So you can test whether something's quick enough just by using it or seeing how quick it is. In the low latency space, however, you care about latencies you can't see. And so you can't just visually check whether something's fast enough. You have to write tools to test the code, to test that it's fast enough, and test that it's fast enough consistently as well. Because often there's a requirement not just to be fast enough on average or to have a high enough throughput, but to be within some threshold 99% of the time or 99.9% of the time. And that threshold can often be so low that if you're not careful, your testing framework can have a higher delay than what you're trying to test. So your testing framework itself may require some iterative development and testing to get it efficient enough to be able to test what it is that it's designed to do. So another feature is that when you're delivering data to a human, you want it to be throttled. You want it to be limited. You don't want to overload a user with too much information. So GUIs can present a lot of information these days, sometimes graphically. But the reality is you don't want to deliver too much to a user, or otherwise they get overloaded. So you want to have reports and summaries and charts and some sort of way of condensing this. However, the sort of data rates that you can send out a computer can often be much, much higher. And so you can expect to have higher throughputs, higher bursts of activity in a relatively short time frame. So one of the examples I often give is that if you go to cinema, most cinemas still use 24 hertz frame rates. So that means that the frame is changing every 24 milliseconds. So, and you can't see that. Most people can't see that. Can't see that or it's not even distracting that the frames are changing. So if you have delays that are less than 24, well under 24 milliseconds, it really isn't going to make much difference. And a lot of solutions are built around that assumption. You can have databases, you can have messaging solutions that say, well, as long as we add a millisecond delay, it isn't going to make any difference. So we'll focus on other things such as more functionality or other features. Whereas in the low latency space, a millisecond is an eternity. You want delays of a millisecond only extremely rarely. Often they'll have requirements. We've had a contractual requirement where the 99th percentile, worst 1 in 100, for running through 3 microservices was under 20 microseconds. So that's from network hop to network hop. So included the OS and the network. So one of the examples of high data rates that we came across is OperaFeed, which is options market data in Chicago. And at one time, they were getting around 50 billion events a day, and in a peak, 10 milliseconds. So they're not strictly low latency because they just get such high data rates. But in a peak 10 milliseconds, in a hundredth of a second, they can get close to 1 million messages. So it's about in the order of up to 100 million messages a second. And obviously that's a kind of data rate which is quite different to what you would ever try and present to a human. That's getting up to the amount of pixels you might have in a high definition video. So but each one of those pixels means something different and very discrete, and you've got to process every one of them. So it's quite different. Another thing about low latency is it really depends on context. Different use cases and have different ideas as to what low latency means to them. And so, so what tends to happen is that low latency often has a business value attached to it. So there is an idea that if the latency is above a certain threshold, that will cost me money, and sometimes they'll have an idea of how much money that will cost. It also tends to mean that they care about latencies you can't see. So a part of the exercise is to write tools to measure the latencies as you go. And they also tend, when they're developing a new low latency system, they usually mean they want to be several times faster than the previous one. But again, that depends on context. So, so one example was a system where they moved from overnight batch to being around a second. So that's substantial. Instead of taking 10, 12 hours, they wanted to do it in a second. Now, for them, that's a substantial improvement. But for a lot of the systems, if you told them they were looking to take a second, they would say, oh, that's not even low latency. So it does depend on context, but you know, there are some common factors between them. So coming back to microservices, people and software tend to work better when there's clear separation of concerns, both in terms of functionality, but in terms of what the developers are doing and what different microservices are doing. And that's one of the reasons why it's very useful even in trading systems. So one of the challenges in a low latency environment is that you want to have very low latency messaging as well. So you want the messaging to be fast enough that it's not creating an undue burden on your SLA in terms of performance. So that's where the challenge lies. In the web space, finding messaging infrastructure that can handle millisecond delays is relatively easy, and there's a lot of good solutions out there. However, if you've got a requirement of, say, under 100 microseconds or in tens of microseconds, then there's no point introducing a messaging solution that takes a lot longer than that. You want it to be a small fraction of your entire latency budget. So one of the approaches we take is a principle we see again and again, both in terms of making ease of testing and performance, is to use a Lambda architecture function. The nice thing about that is that it's very deterministic, very easy to test, very easy to reason about, and very easy to tune. So you have an ever-growing list of events on the input. You have a function which is a result. The resulting message is purely based on each new message. And because it's stateless, it's very easy to fail over and replace. Unfortunately, it's so simple that it doesn't actually fit a lot of business cases. So, so what we tend to do is we tend to have, instead, a function which is not a function of each new message, but it's a function of every message it's ever seen. So all the inputs that could come into a system come in via an event source. That's configuration, anything you might have traditionally gone away to a database to get a hold of, anything you might ask a user, all gets turned into events that are fed in and are completely replayable for things like failover or debugging later, precisely what the state of the system was. And the state is really there to act like a cache, because it's not practical to replay every event every time. Instead, what you do is you maintain a state of all the information you might want to retain to make it easier to process any future event. So you can still get the timings of the previous state, where all you have to do is process each event as it happens, but you get the functionality of having a stateful component. And these can be chained together. So these stateless functions tend to act as normalizing gateways, where you're taking messages from an external system, maybe it's WebSockets, maybe it's JMS, maybe it's Fix, and you're taking messages and then you're translating it to some standard format, your standard DTOs, your internal messaging infrastructure. And then within your infrastructure, you only deal with your standard normalized messages, but these are your stateful components. And when it comes to testing them, the nice thing about them is that all you need is the code. So in the case of the control system, if I want to test that, all I need is the inbound messages and the control system code. That's it. I don't need access to a database that's in production that may have changed state. I don't need access to any external system. I don't need to run up the entire environment. All I need is a set of input messages I want to replay and the control system to test it. And I can replay it to any point. I can debug how a particular message was handled. After changing, I can run it again and see that I've fixed the problem, not a problem based from inferring information in a log. Now notice, because we're recording every event going in and out of the system, there's almost no need for logging. So there's almost, so you tend to have logging for things like startup messages, to say it's successful, or if there's something really critically going wrong in the infrastructure. But for the most part, all the messages, error messages, everything just becomes an outbound message from the system, and there's almost no logging. I can't, certainly in my early career, performance tuning systems that just log too much was a big portion of my job. So I'm grateful to a lot of logging frameworks for giving me a lot of performance tuning work. But yeah, we use them, but we use them as little as possible. Sometimes there might be 1 or 2 lines of logging per million messages, and that's about it. Part of the reason we can do that is that storage is getting cheaper and cheaper. I mean, since I actually made this slide, it's come down even further, but you can get many terabytes of enterprise grade storage for less than £1,000. and even with redundancy is maybe £2,000. So obviously, large banks have interesting ways of inflating this price, but the general trend is that disk space is getting cheaper, even high performance SSDs. And these modules, for example, have a write speed of 2 to 3 gigabytes a second each. And you can have like a huge panel of them all working together. So now we get on to the questions. Katie.
Thanks, Peter, for the awesome discussion on just your programming suggestions in general. We have had one question come through, and I'm sure we'll have some more. Chris asked, I'm hoping to start a new role soon in a new company. How do I make the best impression in these work from home times?
That's a good question. So one of the things that we've been doing as a company is we've been working home for a few years now already. And I think one of the things that tends to make a good impression with me, particularly with my team, is if they're giving good feedback. So it goes back to the effective communication, making me feel like they're doing a lot of work. They're not necessarily a lot of work, but they're considered about their work, and they're giving not voluminous reports, but consistently giving reports, like maybe once a week, some sort of measure of what it is they're doing, and feeling like they're being constructive in terms of what they should be doing. And that kind of paperwork sometimes to developers seems like a hassle or a waste of time, but in reality, like I said, you got to remind yourself that if you do a great job but you just don't tell anyone, what's the point? And it probably is a complete waste of time. So that always needs to be an essential element of anything you're doing, is making sure that it's been handed over, that people know that something's been done, that you're ready to move on to something else if you're ready to pick up something else, and have that consistent feedback. It doesn't need to be lengthy meetings. Sometimes it's a very short email. It doesn't necessarily require lengthy discussion, but to have that constructive, consistent feedback can be very helpful.
Great. And just to everybody else, if you have any questions, feel free to unmute and ask, or you can just throw them in the chat and I'll relay them to Peter. So we have another question. What advice can you give about working as an effective team, Agile, Scrum, cross-discipline teams, etc.? Any preferred, what has worked and has not worked for you?
Depends on how cross-discipline it is. Scrum can work really well if you're working together and your team isn't too large. So there are some guidelines as to what is an effective team size. And some people talk about a number of pizzas that you can feed and things like that. But there does come a point where it is actually more constructive to have a separation of roles between teams that are doing things quite differently. And they can both be run as Scrum projects. They can have the same Scrum Master, same project manager, but the actual meetings between them, the meetings themselves might be quite separate, so that they tend to be discussing things that are at least relevant to the concerns they're looking at. If the team is small enough, then even if you're very cross-disciplinary, it'd be useful to meet together regularly. But if you're a bit larger team, a broader team, and you've got different skill sets, then it might have some sensible division of concerns, and not necessarily. So everyone in the regular meetings gets the time to talk about what they're working on. Whereas if you've got a big team of 20 people, each person doesn't get much time to discuss what their concerns are or what they're working on.
And how do you find the time to answer so many Stack Overflow questions alongside your day job?
The truth is today I don't. um, I'm getting probably less than, I'm well under 1,000 a year now. It was a lot easier when I first started out as a consultant because I only had paid work probably 1 week a month in reality. So I had a lot more time, and it was closer to the earlier days of Stack Overflow. So there's a lot more new and interesting questions I could easily cover. It's a bit harder today, and yeah, I don't necessarily have as much time as I used to do. Yeah, I'd like to think I'm doing about 1,000 a year, but it's probably not that much.
Maybe you have more time for reading then, which is our next question. What programming books would you recommend that don't normally get mentioned?
No, I don't actually get it. See, most of the reading I do is actually online material, something short and concise and specific to a problem I'm trying to solve. So, so one of the simplest things is just Googling error messages. When you get an error message you don't understand, just Google it, try and find out what has caused that. And that's probably most of the reading I do. In fact, I just somewhat humorously added into our error handler, which I called Oh No's. There's one plugin handler that when an exception gets thrown, it will open up a Google search of that exception if there's a browser available. That was a bit tongue in cheek, but it's kind of, there's a lot of mileage in making sure that you search for any kind of error or issue you're having, because there's a good chance someone solved it before, and then reading up on that. And I'd say that's most of my reading these days. Technical reading is trying to solve problems.
All right. And this person wants to be a more knowledgeable and influential developer, but in technical discussions with colleagues, they often feel like they have little to contribute that others in the team don't already know and so don't speak up. What are the important concepts and practices that might help them talk and influence other good developers in technical discussions?
Yeah, so there's a number of it's a number of aspects to it. So everyone is an expert at something. So no one is equally knowledgeable at everything, partly because not everyone's equally interested in certain things as well. So one of the easiest ways to do that is to pick a specialty, especially one that maybe other people don't seem to be interested in. That will very quickly make you the expert in that field, whatever that is. It could be something quite specific and can become something quite small, but it's a starting point. And then you'll find that you will see patterns in, when you become an expert in something, what are the sorts of things that you do? What sort of knowledge do you have? What are the things that you look for? How do you validate your knowledge? How do you test it out? How do you play with that thing? Start small, something that's quite achievable. And like I said, if you pick something that no one else is actually seems to be interested in, that can make it quite easy, because no matter how experienced someone is, there are, like, I'm very experienced in Java. I've been using it for over 20 years, well over 20 years. But there are some aspects that haven't interested me and I don't really know anything about. Someone who's spent maybe just a few days working on it would easily know more than me.
And what do you think of the future of Java?
That's a good question. There's a lot of theories about that, a lot of opinions. So some people come across something they really like an alternative language or some cool feature, and they feel like that's really essential and important. But if you look at Java, I think a lot of the popularity of Java is actually its lack of features. It makes it easier to understand the entire language, feel like you've mastered that language in a relatively short time frame, and it reduces the number of edge cases that occur. And in particular, if you look at the top 10 languages on TOB, if I pronounced it correctly, very few of them are actually newer than Java. So the C#, which is a big one, and that has some functionality that I'd wish Java had. But nevertheless, if you look at others on the list, most of them are older. I think in the top 20, there's only 3 that are younger than Java. So while there's a lot of cool languages out there that are getting some traction and interest, the reality is it's not down to their coolness that most languages are used. They're used because they're practical, and they have an established base which is difficult to just dismiss.
And how would you handle the product guy who takes a simple solution and makes it much more complicated?
Yes. Well, is to really go back to focus on what is the genuine requirement. What does the end user or the client really need? Not all the cool things you would love to have. So I get cool ideas, and I don't like to dismiss them. So what I do is I write them down in a roadmap, which I may never look at again. But I write them down. I keep them. I don't throw them away as such, but I deprioritize them, and then focus in terms of priority on the things that are genuinely required, that are genuinely going to make a difference to a user in the short term. Yeah, so a project I worked on once, they were 9 months into the project, and they were struggling to find any users to test the functionality they'd added. And the reason was that none of the users wanted the functionality. They actually thought it was a bad idea because it sort of meant that they wouldn't need to have as many of them do that job. So they really hated it, even though from an IT perspective, it seemed to improve efficiency, but that was actually what they hated about it. So, really focusing on what users really need, genuinely need, not necessarily sometimes what they would like to have, but focus on what they actually need. And that can cut down that list substantially, and you can make them priority. Now, the nice to haves, you don't necessarily have to forget them, and it doesn't mean that you will never get around to them, but you deprioritize them.
And what do you think of the survival rates that, what do you think the survival rates will be for alternate languages on the JVM, such as Clojure?
See, a lot of programs don't die. Once they get to a certain critical mass, they don't die easily. And Clojure, to some degree, is a modern version of some older languages just running on the JVM. So those concepts don't go away. There may be another Clojure-like language which will displace it completely, but in a way that's not killing off Clojure. It's just creating a newer, better version. I think the programming paradigm that some of these more specific languages have their place, and they're not just going to be dropped just because Java is so popular or some C++ is popular. They don't really solve the same problem. So they won't either become so popular that they displace the big ones, but I don't think the big ones will ever replace them either.
And we're over our time, so I just wanted to make sure that you're still okay to stick around and answer a few more questions that we've had come in.
Sure. Yeah, we could do more questions.
All right, then the next one will be, how did you start building your company, and do you consider open source as a viable solution to build a successful business around?
I would say that it is, and it was for us, but it takes a lot longer than you might imagine. So for us, for this company, originally the open source was kind of a marketing tool. Was probably its best commercial hat description for it, in the sense that people found out about us through the open source products. They use the open source products. I mean, there's some suggestion that people like to have support for open source. I find that's very rare. That most people who use open source, it never crosses their mind that that if they paid for support, that would reduce costs in the long run. Mostly because the developers pick up open source don't have a budget. Then they haven't got a business hat on. They're not necessarily commercially minded. It's not necessarily up to them whether they get support for something or not. So it's not even a question they tend to think about. And on the business side, they often don't particularly care which libraries you're using. They don't look in the details of the library and say, well, is this library supported? Is this library supported? It's not something they necessarily worry about. So unless you're really big like Apache or Red Hat, where again, even on the business side, they don't necessarily know all the details of what libraries or programs you're using, but they know you're using Red Hat. They know you're using a whole lot of Apache stuff. That's the level of detail they're happy with. Then you really need to see it as a stepping stone to either getting more consulting or selling a commercialized product, or which is an additional functionality that you feel that businesses will need or will be willing to pay money for. So I think it's useful as a composite, but unless you're really big, I don't think it's not an easy model at all, because only a very small percentage of people who use the open source are likely to bring you in business.
Thanks. And what does it take to get my first developer job? How can I get there?
Good question. Certainly in this market, I imagine it's quite tough because you're up against developers with a lot more experience who can be in a better position to work unsupervised without assistance from home. So I really, if you can cover that concern, if you can show that you're a self-starter, that you can develop and be productive without needing to sit next to someone more experienced, I think that's going to get you a long way. Obviously, you also sell yourself on the basis that you've got enthusiasm, demonstrate you have enthusiasm and interest in something. Maybe, like I said before, you pick up some new cool piece of technology that is in demand. And then you say, well, what's in demand? Well, I would suggest just doing some analysis. I did this at one point, a bit of CV hacking where it just go through, at the time I was going through JobServe and just looking up technologies. What technologies are people most asking for in their job applications? And put them higher up if that's what I'm interested in doing. Other technologies which I thought were cool and I was very proud to have worked on them, they weren't in demand. So I just deprioritized them or just took them off. So focus on the things which are clearly in demand, and maybe pick up a specialty that someone more experienced doesn't have. So say, for example, a lot of senior developers will know Java 8 backwards, but they won't be necessarily so familiar with, say, Java 14. So focus on, what are the new features in Java 14? What are the new features in Java 15? By the end of next year, I think it's the end of next year, we'll have Java 17, which is the next long-term service release. So there will be a jump to Java 17 all the way from 11. So knowing all the features between 11 and 17 could be an advantage you have that someone with a lot more experience isn't so familiar with.
How much does debugging and error resolution factor into improving application performance?
Debugging, yeah, they're different. So debugging is a big part of a daily cycle. So I use debug a lot. One of my senior developers always runs in debug, just never runs it without debug, which I find interesting. Yeah, debugging should be just a standard part of your practice. In terms of performance, that usually comes from some sort of profile or some sort of tool specifically to track the performance of a running piece of code, and that's comes later, because it doesn't matter how fast something is if it's wrong. In fact, it's worse if it's fast and wrong at the same time. You're better off being slow and wrong than being fast and wrong. One of the expressions is, it doesn't matter how big you dig a hole, how wide you dig the hole, how many holes you dig, but if you dig in the wrong place, it's a complete waste of time, possibly worse than that. So, so correctness has to come first. It's very rare that you come across a situation where correctness isn't as important as performance, but correctness has to come first and then performance. And sometimes the performance is part of the correctness because it has to meet some SLA, but generally speaking, in your first cut, the correctness is possibly the only thing you really need to worry about.
What suggestions have worked best in your experience for profiling Java applications?
So for someone starting out, I've found that just a profiler, standard profiler, I used to use a number of different profilers, but now I tend to use mission control, which isn't as friendly as the others, but it's a bit more low level and does the job quite well. Its main advantage is that you can actively profile a running application without disturbing its performance too much, which of course is one of those Heisenberg problems where you enable the profiler and then it changes the results so that you can't necessarily trust it. Even mission control does that. For example, it tracks where you're reading and writing to a socket and then does a toString on where the socket is. So it creates garbage by trying to monitor reads and writes on sockets. So I tend to turn that feature off just almost straight away, because sometimes that produces more garbage than everything else in the application combined. Being familiar with profilers is important. Being familiar with what it is you can achieve. Don't take it for granted that your application is just going to GC constantly and there's nothing you can do about it. We write applications which are designed to run up to 24 hours without a minor collection. Right? So they produce some garbage, but it's so low that it doesn't actually fill the Eden space in 24 hours. So, so don't just take it for granted that just because a lot of Java applications create a lot of garbage and they're constantly GCing, that has to be the case. It doesn't have to be.
What are the ways to write an object off heap that contains other object references?
Yeah, so the way we deal with that, there's two ways to deal with that, is that you do it via something equivalent to a foreign key in a database. So in a database, you don't have references from one table to another. You have a value in a column, which is an exact match for a primary key in another table. So the equivalent that we do in Java is that we have an off-heap hash map, and that off-heap hash map will have DTOs with values in them, and those values will be keys to other DTOs in maybe other maps. So it's very similar to that concept. So it's not strictly a reference in that sense, because it requires an additional lookup, but it serves the same purpose, with a little bit of having to write some code yourself to look up one, get the value of the fields, and then look up the other one in another map. We do something similar with queues, but that doesn't happen as often.
And speaking of queues, this is our last queued question. So if anybody has anything else, feel free to chime in or type it in. So the last one we have for now is, have you experienced any pain points moving to the module system? And how did you tackle it when working with libraries?
Yeah, for the most part, we've avoided it, to be honest. So we're still building in Java 8, but our applications still run in Java 11, but mostly through compatibility and turning off restrictions. In particular, we use unsafe quite aggressively, and that, of course, is not available in Java 11 by default. So you have to then turn that, enable it again. So you sort of work around the module system in that sense. The part of the problem with the module system, from my perspective, is that it encourages good design practices and tries to stop you from doing things that you probably shouldn't have done in the past. However, it doesn't enable you to do anything that you really couldn't have done before. And if you had a decent amount of discipline, and some people might imagine that they have more discipline than they really do, but if you have a decent amount of discipline, you can just prevent yourself from doing these things. You don't necessarily need a tool to do it for you. But that again, that works well in a small team, which is what we have. In a much bigger team, something that gives you some enforceability of the modularization starts to have a lot more value. But that's not really our use case.
Great. Thanks so much for taking the time to answer all these. We don't have any more questions for now.
And thank you,
So,
everyone, though. And thank you, Katie.
So, and thank you for putting up your contact information on the screen. So if anybody, wants to reach out to him or, add him on LinkedIn, there's some information for that. Peter, did you have anything else you wanted to add?
Yeah, so we've got a performance engineers group, but it's also easy to find me on LinkedIn, and happy to add. And thank you, everyone.